Good day, students. Today we're going to have another lesson, which is a continuation of our lesson in vectors. This one is the part 2. And this is going to be about directions of vectors. Remember that the most distinguishing characteristic of vectors are their directions. That's why we must understand how directions affect the computations and the way we analyze vectors. We can have the following conventions in designating or determining the directions of vectors. We can use the cardinal directions, the normal directions, the up, down, right, left, and we can also use something that is based on the Cartesian coordinate system. Okay? But um, we're going to know more about them one by one. Let's have the cardinal directions first. When we say cardinal directions, these are the directions that you will see in the compass or in the map. That's basically the northeast, southwest, and then the directions that have them in phrase. Okay, so basically we can categorize the cardinal directions as primary, secondary, and tertiary directions. Now we're going to start with the primary directions. The ones encircled and boxed are the cardinal primary directions, and each direction is actually associated with a positive or a negative sign. If it's north and east, we can associate it with a positive sign, and then the south and west is associated with the negative sign. So what's the importance of the positive and negative sign? In uh, vectors, the positive and the negative sign only tell you the direction. And in a specific given, if the direction of the vector is going to the positive direction, the numerical value should have the positive value or the positive sign rather than the um, direction. And then if it's going to the negative direction, we should indicate in the given the negative sign. So basically, in computations, that's when we transform the direction itself into the associated sign. Because if you don't input in the given, also in the equation, the substitution of in the equation, you will get the wrong answers. So that's for the primary directions. Let's have some examples. Here is an example of a grid line. So we're going to follow the um, scaling of vector diagrams, and let's use a scale that is 1 square is equal to 1 meter. Okay, instead of the measurement in the ruler, you can also use the measurements or the grid lines of a graphing paper or any graphing material with squares in it, no? So let's have four examples for vectors. First one, let's say that we have this orange arrow that represents vector A. How do we know the magnitude? We're just going to count how many squares does vector A um, an, uh, over ano tawag doon? Nasasakop of the vector A, okay? So let's use dots to count each square that vector A covers. Yun, cover. 1, 2, 3, 4, 5, 6. Therefore, the magnitude of vector A will be 6 meters. Now, in what direction? As you can see, the arrowhead of vector A is going to the east. So, we can write vector A as A in bold letter. The letter A should be in bold. boldface, is equal to 6 meters east, or if you're going to write it as a given, it should be positive 6 meters. Okay? Next, let's have vector B. Let's say that this blue arrow is vector B. Ayan. And then we're going to count again how many squares it covers. 1, 2. Therefore, the magnitude would be 2 meters, not 2 squares. Remember, that's the rule for scaling. And then it's going to the west. So we can write B or vector B as equal to 2 meters west, or it can be negative 2 meters. Okay? Next, let's have vector C, this green one. Let's count again. 1, 2, 3, 4. So, this one is a vector that is going to the south. We can write vector C as C is equal to 4 meters south or negative 4 meters. And then lastly, we have vector D. 1, 2, 3, 4. And then we can write it as D is equal to 4 meters north or positive 4 meters. So remember again, let me just emphasize that the positive and negative sign only tell you the direction. Meaning, negative 4 is not less than positive 4. They are equal in magnitude, but they are going in opposite directions. That's the meaning of the positive and the negative sign. Kasi 'di ba normally in the number line or in algebra, when we say negative numbers, they are less in value compared with the positive numbers. So here in vectors, the signs do not tell the value kung sino yung mas malaki o sino yung mas mababa if they have the same numerical value. No? Pareho silang 4. It's just that the negative 4 is going to the negative direction and then the positive 4 is going in the positive direction. No? Walang kinalaman yung sign nila kung sino yung mas malaki, sino mas maliit. Especially when they have the same numerical value. Okay? Okay, after having examples for cardinal primary directions, let's proceed with examples for the secondary directions. But first, I'm going to explain what are the secondary directions. So in here, I will encircle and box again the secondary cardinal direction. Each direction this time is not associated with a specific sign, but it is associated with a specific angle. Basically, the secondary cardinal directions are the northeast, northwest, southwest, and southeast. When we say northeast, that's 45 degrees relative to north and east. And then when northwest, it's 45 degrees relative to north and west. If it's southeast, it's 45 degrees relative to south and east. And then if it's southwest, it's 45 degrees relative to southwest. Well, what does that mean? It means like this. If this one, no, let's draw, no? Look at the drawing. Pardon me, I'm using a mouse that is not making a very good line. Ayan, the red line. Okay? So we have here the red line. When we say relative, it means that you measure from that direction. So the 45 degrees relative to north and east means that, diba this one forms 90 degrees. Ayan. Okay. So if you put together north and east, it will form 90 degrees. And then pag hinati mo yung angle, 90 yon, no? If you divide it equally, you will get two 45-degree angles here and here. When we say relative to north, if you use the protractor, your zero must be starting from the north, and then you measure from the north towards the specific vector. Ayan, na northeast ang direction. That's supposed to be 45. And of course, if that's 45 and this is 90, wala nang tanong-tanong, wala nang measure-measure. You know that this one is 45 as well. Diba? So that's the meaning of 45 degrees relative to north and east, north and west, south and east, and then south and west. So these are the secondary directions. Now let's have some examples. Here are our grid line again. Here is pala our grid line again. And this time, instead of using the squares as our scale, we are going to use a virtual ruler. Every 1 centimeter is equal to 1 kilometer. Bakit siya virtual ruler? It means that it's not the same measurement as you will get if you use a ruler and then you put it on the screen, no? Hindi siya ganon. So, virtual ruler lang siya. Okay? So for every 1 centimeter that we get from the virtual ruler, that means it's equivalent to 1 kilometer magnitude. Okay, so let's have the first example. Ayan, we have again vector A. So always I'm going to use for examples, and then I'm going to name them vectors A, B, C, and D. Para mas madali siya. But you can also use other uh, letters. Remember that, di ba? In our past lesson, okay? So, ayan, that's vector A. And then, we're going to draw some guidelines, the yellow broken lines. Those lines will tell you which directions are involved in vector A. So, this time, as you can see, the directions involved, the cardinal directions involved are north and east. So basically, alam mo na agad that this direction must be northeast if these two angles are equal to 45 degrees. Okay, so let's assume that using a protractor, a virtual protractor, those two angles are 45 degrees. Okay, so if that's the case, we can write vector A by getting its magnitude first. So according to our virtual ruler, the measurement is 7 centimeters. Therefore, we can write vector A as A is equal to 7 kilometers northeast. Later on, you will see that there is a similar direction. Para siyang similar, sounds similar but different from northeast. That's why I personally categorize them into three para hindi tayo magkalito-lituhan kapag mag-usap-usap tayo, no? Ayan. So that's the first example. Let's have, but don't worry that you don't need to always use virtual rulers or rulers itself so that you can solve things or measure things in vectors. We can use computations to get magnitudes. So these are just examples using rulers. Okay. So let's have the second example. This time we have vector B. Again, we're going to draw guidelines which will tell us that the directions involved are north and west. And then again, assuming that these two angles are equal, um, we would know that the direction must be northwest. Okay? Now let's measure the magnitude of vector B. Ayan. So, according here, medyo lumampas siya ng 5, but let's assume that it's exactly 5, no? Para mas madali niyong makita. Okay, so let's say that this is 5 or mga medyo 5.2 siya. So, let's have it as 5 na lang, no? And then, we can write vector B as 5 kilometers northwest. Now let's proceed to the next. This time, we're going to have vector C, and if we draw the guidelines, we can identify that the directions involved are west and south. So we would know that if these two angles are equal, the direction must be southwest. And then using again our virtual ruler, approximately the measurement is between 7 and 8. So we could identify that the measurement is 7.5. Yan, kasi medyo the tip of the arrow reaches the exact line between 7 and 8. Therefore, we can write vector C as C is equal to 7.5 kilometers southwest. Okay? Now let's have our last example for the secondary cardinal directions. Let's have vector D, and then again let's have the guidelines which will tell us that the directions involved are south and east. And then again, assuming that the two angles formed are equal to each other and equal to 45 degrees, we can get the magnitude this time of the vector D using our virtual ruler. And approximately, ayan, the head or the tip of the head of the vector tells us that the measurement is between 4 and 5. So we can assume that it's approximately, kung titingnan mo, it's medyo lumampas siya ng 4.5 pero sabihin na lang natin siya 4.5, no? Para mas madali. Okay? Let's write vector D as 4.5 kilometers southeast. Yun, ganun lang siya kadali, no? So this time, these are the cardinal directions that are quite confusing, okay? So I'm going to show you two types, but we're actually going as to use the tertiary directions relative to x-axis. Meaning, in our computations, in answering problems, in adding vectors, we're going to use these directions. But I'm also going to show you the tertiary directions relative to the y-axis. So that when you look at other books, baka kasi malito kayo, magtanong kayo, why ma'am, it's like this in this book and then in the one that you taught us, ito lang, no? So I'm going to show you two, the tertiary directions relative to y-axis. But let's start with the one that is relative to x-axis first, okay? Okay, just like the secondary directions, each direction is associated with an angle. But this time, it's not just one uh, individual specific angle. There is a range of angles you can associate the direction with. Yan siya. Okay? So we have here, as you can see in the secondary direction, we have northeast, northwest, southeast, southwest, right? There is no off. That's the difference between the secondary and then the tertiary. This time, meron na tayong off. So, anong pinagkaiba? The main difference, if you will see, if we say north of east, that's a direction with angles between 0 to 90 except 45. Okay? Anong ibig sabihin nun? The values of the angles must be 1 to 44 or 46 to 89. Okay? Doon siya, in between siya doon sa range ng angle na yun. Again, it should be 1 to 44 kasi except 45 nga. And then, um, 46 to 89. So, hindi siya magzi-0, hindi siya magni-90, and it won't be also a value of 45 degrees. If it's 45 degrees, you already know that it's not gonna be north of east. There is no off. If it's 45, there is no off. Okay? But if it's not 45 and it's not 0 and it's not 90 degrees or it's not exactly on the north, on the east, on the south, on the west, you would see the word off. Okay? So if it's north of east, it's associated with angles between 0 to 90, except 45, measured from north to east. When we say relative to x-axis, it means this. If you consider this as the Cartesian coordinate plane, it has two axes, the x and the y. And then we also have the positive x, and then the negative x, and then we also have the positive y, and then the negative y. The positive x-axis is the same as the direction east. The negative x-axis is the same as the direction west, while the north is the same as positive y-axis, and then the south is the same as negative y-axis. So when we say that the direction is relative to x-axis, it's either relative to the positive x or the negative x. So, relative siya sa east and west. Pag sinabi nating relative or measured from or with respect to, pare-pareho lang yon. Ibig sabihin nun, you start measuring the angle from a specific direction. This time, it's either you start from the east if the vector is at quadrant 1 and 4, o kaya naman, you measure the angle relative to negative x-axis if the vector is at quadrant 2 and quadrant 3. Remember that in the Cartesian coordinate system, we have 4 quadrants. 1, 2, 3, 4. Kindly recall so that when I speak of them, you would be able to understand what I'm talking about the quadrants and all. Okay, let's proceed. When we say naman north of west, that's measured um, uh, between 0 to 90, except 45, measured from west to north. If it's south of east, it's east to south. You start from east, you go to south, and then we have also south of west that is measured from west to south. I'm going to show you how the rotation or the movement of the angle should be. So be careful and attentive. Ayan. Okay, so as you can see, the red curve moved starting from the east going to the north. Okay, so those are the possible positions for the vectors that has the direction of north of east. Galing sa east, papuntang north. And then we also have the north of west, coming from the west, going to the north, indicated by the yellow curve. And then we also have south of east, so galing siyang east, papunta siyang south, ayan, indicated by the green curve. And then we also have south of west, which means that the measurement starts from west going to south as indicated by the navy blue curve on the picture, no? So those are for the tertiary directions relative to x-axis. Okay. This time, let's have the one that is relative to y-axis. Again, they have the same associations with the angles. It's except 0, 90, and 45. But this time, as you will notice, the directions interchange. So, kanina, dun sa relative to x-axis, we have north of east. This time, it's east of north. Baliktad na siya. O, tingnan nyo. We have, instead of north of west, we have west of north. And then, instead of south of east, we have east of south, and then instead of west of south, we have instead of south of west rather, we have west of south. So ano yung difference nila? The difference is that This time, we measure relative to north and south, because remember, north is the positive y-axis and then south is the negative y-axis. Again, I will show some um, uh, lines, animation that will show you the rotation. So, pag dun sa east of north, it starts from the north, ayan, as indicated by the uh, red curve. As ang movement niya, galing siyang north tapos pumunta siyang east. And then, we also have west of north. Ayan, so galing siyang north, pupunta siyang west. And then, we have east of south, which means that it started from the south going to the east. And then lastly, we have west of south that starts from the south going to the west. Okay? Yeah. So let's say that I use the same magnitude for the cardinal secondary directions for the vectors that I'm going to use as examples naman for the tertiary. Okay? Same magnitude lang siya. So this time, minove ko lang siya ng konti so that the angle will not be 45 degrees anymore. But we're going to use the same scale. 1 centimeter is equal to 1 kilometer. So basically, again, ulitin ko, no, baka makalimutan ninyo, the measurement of this arrow, kung gano'n siya kahaba, is the same as the measurement that we've used in the secondary directions. Ito rin yun, inusog ko lang yung angle, okay? So, let's have vector A here, and then the magnitude, I forgot na later it will be revealed. So, let's say that, using the protractor again, let's assume that we have an angle relative to the x-axis. So that's relative to east. Ayan. Let's say that this one is 59 degrees. And then we have the magnitude of vector A. Since 59 degrees is relative to the east, it's relative to x-axis. Okay? So we can write vector A as A is equal to 7 kilometers, 59 degrees north of east. As you will notice, during the examples for primary cardinal directions, we don't include angles. It's associated with a sign. So what you write is, you may write A, or the letter that represents the vector, the equal sign, the magnitude, and then comma, the direction, either north, east, south, west. That's the format, di ba? Tapos naman, in the secondary direction, we have the letter again that represents the vector, and then the equal sign, and then the magnitude together with its unit, and then comma, either northeast, northwest, southeast, or southwest. Diba? No angle is written because it is understood already that if it's northeast, northwest, southwest, and southeast, automatic 45 degrees yun. No need to write. But this time, since the angle is not specific, it has a range, you have to indicate it. So this time, the pattern would be, hindi mo na ilalagay yung relative to x-axis ha, kasi understood na kapag north of east yan, you measure it from the x-axis. Okay, again, di mo na isusulat yung relative to x-axis if nakalagay naman na yung direction, because it's automatic that when you say north of east, that's relative to x-axis na. Okay? Okay, so the pattern would be like this. The letter or the variable that represents the vector, equal sign, the magnitude, syempre, don't ever forget the unit, the specific angle, and then the direction. Okay? Yun yung pattern niya. So, how about if it's relative to y-axis? Again, ulitin ko, our convention would be relative to x-axis. I'm just going to show you how it is expressed relative to y-axis. Meaning, kung ano man yung expression niya relative to y-axis, it's equal. Equal sila. Magkaiba lang sila ng angle at direction. So, ito. Siyempre, if 90 minus 59, we don't need to use the protractor, automatically that's going to be 31 degrees. So if we're going to write vector A relative to y-axis, it would be A is equal to 7 kilometers, 31 degrees east of north. Okay, now let's have vector B, and let's say that this angle relative to west is 20 degrees. And then again, we're going to use the magnitude of vector B that we used in the secondary direction. So we may write vector B as B is equal to 5 kilometers, 20 degrees north of west. And if it's relative to the y-axis, again, we subtract 20 from 90 degrees. So basically, this is going to be 70. And we can express vector B relative to y-axis as B is equal to 5 kilometers, 70 degrees west of north. Now let's have vector C. And let's say that the angle relative to west, again, relative siya ulit sa west, but this time in the third quadrant, let's say that it's 15 degrees. So, using the magnitude from the secondary directions, the examples from the secondary directions, we can write vector C as 7.5 kilometers, 15 degrees south of west. And then, again, ma-minus lang din natin, we have 75 degrees. So, we can also write vector C in terms of the y-axis, which will be C is equal to 7.5 kilometers, 75 degrees west of south. And lastly, we have vector D. And then this angle, let's assume it's 80 degrees. And then the magnitude of vector D will be the one, again, coming from the secondary direction examples. We can write vector D as 4.5 kilometers, 80 degrees south of east. And in terms naman of y-axis, that's 10 degrees. So we can write D is equal to 4.5 kilometers, 10 degrees east of south. Now that we're done with the cardinal directions, primary, secondary, and tertiary, relative to x and relative to y, let's proceed with the directions that we normally use in everyday life, no? Up, down, right, and left, because we also use this in physics. Okay? We can also pertain to up as upward, down as downward, 'di ba? Right as rightward, leftward, ganon. Pwede rin siya, no? So we can express it that way. And para lang siyang yung sa northeast, southwest. Okay? The up and then the right will have the associated signs of positive. Ay, sorry. The down and left kanina will be associated with uh, the negative sign. Okay? So let's have the examples. I'm just going to get the same examples that we have uh, in the cardinal primary directions. So we have vector A, ayan siya. And then instead of north, east, we can use right. So same principle, we just change the name of the direction. And then vector B will be, instead of west, we use left. For vector C, instead of south, we can use down. And then for vector D, instead of north, we can use up. But it does not mean that if the problem uses north, you can use in your answer or in your final answer the direction that is up. Okay? So kapag sa problem, ang ginamit, up, down, right, left, dapat isa sa yung magiging direction of your final answer. If the problem gives you the one that has northeast, southwest, your final answer should be associated with those directions. Huwag mo siyang i-interchange kapag nasa problem siya, no? So this one is just an illustration that instead of the cardinal primary directions, we can use up, down, right, and left. Okay, let's have the Cartesian coordinate system.